Okay, we've got an implicit equation. People don't like stuff that isn't y equals, but sometimes equations aren't as simple as that. So here we've got a relationship between the y coordinates where the y coordinate squared plus the y coordinate equals the x coordinate cubed plus 2 times the x coordinate. And they're giving you a little sketch to show what it looks like. So this is the curve here going down and out like that, and there's the vertical line x equals 2. First thing it wants is the points of intersection between the line x equals 2 and the curve described here. So when you've got points of intersection between two things, for every point on the line we can say that it's true that the x value is 2, and for every point on the curve we can say that if you do that to the y coordinate, it's the same as when you do that to the x coordinate. So when they're both true, x is 2 and this is true. So I think it's not a massive leap to realize that you just need to substitute x equals 2 into this expression and you can find out where they meet. We already know that the coordinate's going to be 2 something here and 2 something, so we just need to work out what y is. So if we sub x is 2 into this, we get y squared plus y equals 2 cubed plus 2 lots of 2, which is 12. So if y squared, what did I say, y cubed? Y squared plus y equals 12. Then y squared plus y minus 12 equals 0. And you can either do Pythagoras or you can realize that this factorizes. We get y plus 4, y minus 3 equals 0. And so we get y equals 3 or minus 4. But remember that these are points, and we already know that x is 2. So the coordinates here are 2, 3 for the top one and 2, minus 4 for the bottom one. The intersection points between the line and curve. Find dy by dx in terms of x of y. Now, if we're differentiating this implicitly, we don't need to rearrange to make y the subject. We can just differentiate each term with respect to x. Now, when you differentiate y squared with respect to x, that's the same as when you differentiate y squared with respect to y and then multiply that by dy by dx. Effectively, the dy's cancel and you're left with dy squared by dx. Differential of y squared with respect to y is just 2y. You know, if you differentiate x squared with respect to x, you get 2x. If you differentiate y squared with respect to y, you get 2y. And then times dy by dx. The dy by dx you leave, which a lot of people are uncomfortable with. But yeah, that is what the differential of y squared with respect to x is. It's 2y dy by dx. The differential of y with respect to x becomes dy by dx. So this bit becomes 2y dy by dx. This bit becomes dy by dx. If you differentiate x cubed with respect to x, you get 3x squared. If you differentiate 2x with respect to x, you get 2. Now, to find dy by dx, that's what we get when we differentiate each term with respect to x. So I'll just write that out here. To find dy by dx, what we need to do is to make dy by dx the subject. Now, whenever you're trying to make something the subject and it appears more than once in your formula, you're going to have to factorize to turn 2 into 1. So to turn 2y dy by dx plus dy by dx into 1 dy by dx, we take that out as a factor, and we get dy by dx times 2y plus 1 equals 3x squared over 2, 3x squared plus 2, and then divide by the 2y plus 1, and that is our expression for dy by dx. And some of you are saying, but hey, it's got y in it. That doesn't matter. As long as we know x and y, we can work out the gradient at that point. And actually, if we just know one of them, we can sub it into this equation to work out y if we need to. Anyway, we've got dy by dx in terms of x and y, which it said we needed to do anyway. And it says, hence find the gradient of the curve at each of these 2 points. Which 2 points? The points from the previous part of the question, these ones here. So let me delete all this stuff to make some space quickly. Right, so we're going to sub these points into this expression. So when x is 2 and y is 3, we get dy by dx equals 3 times 2 squared plus 2 over 2 times 3 plus 1. 3 times 2 squared is 12 plus 2 is 14 over 2 is 14 over 7, which is 2, and that's at 2, 3. And at 2 minus 4, we sub it in and we get 3 lots of 2 squared plus 2 over 2 lots of minus 4 plus 1, which is 14 over minus 7, which is minus 2. And those are the gradients. The gradient at 2, 3 is 2, the gradient at 2 minus 4 is minus 2, so we've actually answered the question. Oh, it's deleted the bit that said hence find the gradients of those 2 points, but dy by dx at the 2 points gives us the gradient.